To simplify this expression, we'll first look at the fraction and see if there's anything that we can simplify. There are no like terms on the top and the bottom, so the next step will be to use the quotient rule and rewrite this as two separate radicals. So we'll have the square root of 7x to the 6th y cubed over the square root of 8z. I will now simplify each of these radicals by rewriting each in terms of their perfect squares and non-perfect squares. So in the top, 7 is not a perfect square. X to the 6th is. Y cubed is y squared times y. And I'll place this 7 on the end because it's a non-perfect square. In the bottom we have 8, which is 4 times 2. So I can rewrite this as 4 times 2 times z. I can now simplify this. The square root of x to the 6th is x cubed. The square root of y squared is y. And we're left with 7y in the top, the square root of 7y. In the bottom, the square root of 4 is 2 times the square root of 2z. Now, I'm not done simplifying this expression because we have a radical in the denominator. So the next step is going to be to rationalize the denominator. I'm going to do that by multiplying by a fancy form of 1, and that fancy form of 1 will be the square root of 2z over the square root of 2z. That will allow us to get rid of this radical when we multiply. So when I multiply, I'll have x cubed y. The square root of 7y times the square root of 2z will give us 14yz. On the bottom, we'll have 2 times the square root of 2z times 2z, which is 4z squared. Simplifying the denominator, another step, will give us 2 times the square root of 4z squared is 2z, and so we end up with x cubed y times the square root of 4yz all over 4z.